that you are going to do manually. For instance now, let's say that here you want to find the correlation of the study score and test score, for instance. So if you click on your data set, you come to data here. If you don't have data here, you go to file. When you get to file, you click on option. By this time, I think all of us should have data in our this thing, data analysis in our Excel. So just click on adding. So when you click on adding, hope you have that analysis. So no need to go through that process again. Yeah. So when you click on add-ins, so under the add-ins here, you will see analytics to pack. So just click on analytics to pack. It's going to come up at the top behind the and data ribbon. So when you see that one there, so this is it. Click on go. Then mark this one, analytics to pack. Then click OK. So it's going to so you now click on data here, data analysis. Tẹ́ bá ti rí data analysis, ẹ máa lọ sókè, ẹ scroll lọ sókè. Ẹ máa rí correlation ní below. Okay. Ẹ wá click OK. So under the input range, ẹ select gbogbo table. Tẹ́ bá ti select ẹ click lórí label. Tẹ́ bá ti click lórí label, ẹ wá click lórí output range. So let's say that we want it to be, our result to be here. So then click OK. So you see, this is our correlation here, and the correlation here is very strong. So that means we have 0.9688 kineton. So we say that there's a significant difference between this. There's significant difference between this data set. So and if you look at this, the study score, the study hours and test score. So the study hours determines your scores in the test. If you study for 2 hours, you have 50 score. If you study for 3 hours, you have 55 score. If you study for 5 hours, you have 65 score. If you study for 16, 18 hours, you have 92 score. So it has a significant effect. So study hour has a significant effect in your test score. So that's why we have a strong correlation here, which is 0.9. So and if you have anything like 0.7 upward, it's a strong correlation and it's very good. So that's just the interpretation of the result of what you are seeing here. Do you see? Do you get that? So now also we also have regression here. So we want to perform regression too. We click on data analysis here, then come down a bit. You click on regression under this behind the rank, then click OK. So you select this one for input Y. So and this one for input X, that's the sales revenue. So after you did that, you click on label, you can find the confidence level or any other thing. You can residual, high spots, standard, clinical. So if you want it, you can select everything actually. Then constant is 0. So you click OK. Hey, wait. And this one open a new sheet. So can you see these are results actually? So here we have a strong regression too as well. You have 0.99 something, 0.99 something here too as well. So and our p value is very low. Our p value is 0 point this, and a critical value Let me check the significant level. Our critical value is 2960. I mean 2760. Yeah, at this point. So you can let me just highlight so that you can see it. So here we have it to be this, and the p value is this. So and then our p value is lower than the critical value. So and if p value is lower, you understand? If p value is lower than f value, which is your calculation value. I'm taking you to statistics. You may not even understand what I'm saying, but if you are doing like project analysis, so these are the things you have to know. So here we have this one here higher than this. Because this one is higher than this now, there's no significant level difference between them, because we fail to reject null hypothesis. So we fail to reject null hypothesis like this, because this one is lower while this one is higher. But if this one is higher and this one is lower, so that means we reject the null hypothesis. You understand? So that's just the input a little bit explanation I can give. This one here we have it in the multiple R. The multiple R we have that one in ANOVA analysis, and R square tools and ANOVA analysis. So and the ANOVA analysis table also is here. So we have a degree of freedom. GF stand for degree of freedom, while this SS stand for sum of the square, while M and S, the M stand for measure of square, and also we have F, that's F ratio, F statistics. So and no, I'm just teaching you now. That's why I told you that I will just explain from the scratch. I will explain the regression analysis, how to do it. I did it, but I not explain it like this. Yeah, I did it. I think I did only regression that day. I did only regression that day. It's not everything, but I did not teach. I did not explain it like this. Do you understand now? So here, that's how to do the regression analysis. You can also carry some chart here. Àwọn chart tó ṣe ẹ lè gbé sínú project yìí, so that you can use it for better structure of your analysis. So predicted marketing trends. So the sales performance now, you can see that this dot that have the red one is a predicted marketing trends, while the blue one that is behind it is a marketing trends, marketing spend. That means the spend in the market. So and that one can be fixed into the marketing spend here at the top here, because the data set given to us. So and the normal probability plot too is there. So now let's go to ANOVA. ANOVA, one way ANOVA, we want to perform this. Mo ṣe lè tẹ́lẹ̀ àbí ṣé a ti ṣe é ni? Have you done one way ANOVA? Ah, oh. I think I use this to explain something for Mr. Bayo this afternoon. Someone asked for it, so I use it to explain someone for someone. So now here we want to perform method this one way ANOVA. So you want to do one way ANOVA, you will click on this data here as well too. So you click on data analysis. Then after you click on data analysis, you will now click on single factor. Single factor means one. So if you click on this one ANOVA single factor, click OK. So after you click OK, you select all this from A. ANOVA is an analysis of variance. It's analysis of variance, and it was being created by Ronald in 1925. The man is working in an experiment, is design experiment whereby you focus in agriculture actually. You look at how to generate a revenue, how to make a product to grow very well, how to um plan your schedule before you start any productions in agriculture and all. So that you use agriculture field as the first experiment you made before you now navigate to other field now that people are using it, design experiment to use ANOVA analysis to do a lot of analysis now. So ANOVA analysis is meant for detecting of your experiment. Let's say that you want to do, let's say you want to do bóyá ẹ fẹ́ ṣe pop off, ẹ wá fẹ́ wo taste ẹ̀ bó ṣe rí, for instance. So you want to look at how the taste is, how the quality is, and how people really getting, like, having the interest to get more of it, or how they are like avoiding it, something like that. So you can use this design experiment to do that. So whereby you set a questionnaire, so they will fill the form. So the feedback you get from there, you input it in your SPSS or Excel or any data analysis tools. So after you input the data set, then you now perform this ANOVA analysis. The result that is going to give you now, that's what I'm going to show you now. For instance, now we have a one way ANOVA here. So after you select this one for this table, then you click OK. So it's going to show the result here for you behind this. So here we have the count, we have sum, we also have the sum, we also have the average, we have the variance. So and here we have the ANOVA. So this one here, Mr. Lide, this one here is, I told you before that um data analysis is, if it has a little bit mathematics. So yes, so now yeah, we have p value to be 0.9 lis ten, which shows us that it's very strong. So this is how we got all this stuff manually. Eléyìí tó wà níbí báyìí, I will do this one for you. For this total, okay, no, wait oh, I'm coming. The table that you got here is wrong. The reason why I say it's wrong is because the total we have here, a ti lọ ka total kan mọ́ tí ò dẹ̀ yẹ kó sí níbẹ̀. That total is not supposed to be there. So here at this point we delete this one here. So these are the calculation of the total set, total of everything here. We add this one together. We add this one together. That's what we have below before. So let's delete it. Then let's perform it again. Come to data here. Then click on data analysis. Then click on one way and over. Then after that, select your range. Select your range. So from here to this part. So after you do that finish, click OK. So it's going to come up here. So we have our total sales will be this. So how do you got that manually? So let's say we have two here at the top. So for instance, so now all this one now, for instance, now let's say we have equal to here. Then you write SUM sum, then open bracket. But so press enter. So and also this one too. Let me just copy it, paste it there. So let me just that's how to do the one way. Let's do two way. So this one actually, is the result you need o. Nǹkan tẹ́ ẹ fẹ́ rí gangan leléyìí. Gbogbo answer tó wà níbí, nǹkan tẹ́ ẹ need leléyìí. Ẹ kàn lè copy ẹ̀ báyìí or kẹ́ ẹ screenshot ẹ̀, kẹ́ ẹ paste ẹ̀ sínú iṣẹ́ yín, and that's all. So here too, if you want to do the two way and over, you click on data here. So when you click on data, you click on let's say without replacement, for instance. So now you now click on select your range, all the table. After you select all the table, then click OK. So it's, I'm coming, replacement input range. For this, let's click on output range to be this. Our output range will be here. So now, then what again? Let's select only the tradition and this. So you select from this place to this part, then click OK. So this is our ANOVA, two ANOVA, whereby you have the variance to be this. Our variance is not there's no value for it. So this is our variance gangan níbí báyìí. So here we have a variance to be this 78, 80 kìíní kan gbogbo ẹ̀. So the thing that we are looking for is this tó wà níbí báyìí, score. So adding up of this one together, then we have 12. Adding up of this one together, we have this 973. You can create a new one, create a new one, create a new one. We have to finish this.